Hey everyone, so the Pixyz plugin video that I did just as an overview did really well. I had a few questions come in about going more in depth with pulling an asset through. So I'm going to go through that right now. So we're going to deep dive one asset coming in. It's a CAD asset that I'll be using, but similar rules could be applied to Revit, could be applied to Point Cloud. We'll bring it in, see what issues it has on import, as far as what we want to clean up, what we want to optimize, and we'll take it from there. So first thing we need to do is go into Pixyz, the Pixyz menu up here. I've done a previous video that I can link where I've talked through how to install Pixyz and how to get up and running. And we have a lot of settings here. I'll spend 30 seconds on this. So we have the import model, which is where I'll be living for the most part. We have create import settings, which I could get into if I want to change some of the import settings and customize that to be reused over and over again. A few other settings that we'll skip over for now. We have the toolbox, which is a way to do most of the processes by hand manually. Then we have the rule engine, where you can create a string of processes that all work with some manner of intelligence and filtering. We have some LODs that we can then generate within the engine itself. And then a few other things down here, such as documentation, license manager, support, things that we won't go into in this video. So what I want to do first is go into Pixyz import model. And this is a model that I found online. I do want to make sure that I give credit to the engineer that built this. His name is Wolfgang Gottlieb. And let me flash his GrabCAD website very quickly so that I ensure that I want to give credit to the engineer that created this asset. And here it is. So this is the asset as I found on GrabCAD. It's just one of many free assets that are out there. So I pulled it in. It's an inventor file. So it comes in with parts and assemblies, which I thought was a great example of how you might see something coming into your own software. So this is native files. It's not STEP. It's not FBX. Nothing has been converted. Without further ado, let's pull in what I believe and have found to be the master assembly file. So I'm going to go ahead and hit open. And now that we're in here, we have default import settings that we could play with, as well as some importing. Do we want metadata, lines, points? What scale do we want to pull it in at? Hierarchies. Do we want to generate LODs? Among other settings. Again, we've made other videos going through each of these, so I'm going to speed through this. The only thing that I'll say that I usually do that I'm not going to do this time is to generate LODs, because a lot of the rules that I want to use later on in this video would essentially override the LODs and start to merge LOD levels together, and it just gets a little sloppy. So what I want to do instead is to create LODs at the end, and I'll leave that checked off for now. So we have no rule set created yet that we're using, so we're just going to hit import and see how this comes through. So this is now importing and doing some basic tessellations for us. So let's come over here and look at this model. Looks pretty good on import. It looks relatively clean. If I come over into the game window and look at the stats, we're looking at, it says 2.1 million tries right now, a little toasty. So my goal here is going to be to clean up this hierarchy, get it optimized, potentially even build in a small amount of animation, and then could redo all of this for the most part solely on the import. So let's go ahead and open up the hierarchy here. I can see already it's not only in a different language than I natively speak, but it has a lot of children inside of each of these objects that are called things that are not important to what we want to care about within the naming convention. So the first thing that I want to do is that I'm going to want to merge this by final level so that it merges it up one. And we'll probably also want to set this model for the most part to static, though I would like to do some animation and dynamic movement on the rotor blade itself. But we will get there when we get there. So The way that we're going to do this is we're going to go to Rule Engine, create new rule set. I'm going to name this rule set down here, engine_demo. And then over here, we have in our inspector what appears to just be a plus sign and a run button. So if we click that plus sign, we can see that we've now created a new rule, and each new rule essentially needs something that it's pointing at or referencing or going to apply the new rule to. So the first thing that we want to do is hit the plus and say get, and we'll say last imported model or latest imported model. And that way it will kind of self-reference. So if I later apply this in an automated way at the import phase, it's not going to import and be looking for a specific game object that doesn't exist. It instead is going to be importing and then looking at itself immediately. So that's how I want to refer to this model throughout this exercise. I want to come in here and go to hierarchy. And then I believe we'll want to do a merge, and we'll merge by final level. So that will pull up each of these, and I'll leave this hierarchy open so that we can see it. I also want to go ahead and just make it all static. So I'm going to hit set as static, and then we can make the rotor blade itself not static later on in this sequence. So this new rule, I would basically just call default import clean, because we're not just doing a straight import, we're doing a couple mergings, and we're also setting it to static so that we don't need to worry about it. So if I hit run now, let's watch the hierarchy on the left. And we can see that all of these children that were extraneous are now merged up into the parent. So we've kept the naming convention. We've also kept the metadata that pulled through with this model, which is very important. So that all looks as intended, and I also see that static has been set for all of these objects, which just means later on, if we customize this scene a bit and light it and use something like baked global illumination, that we're going to be able to see that properly and apply that properly. So the next thing that I want to do is probably go ahead and pull out the nose and the rotor blade. So I see here that they are named NOS and propeller. And I also see down here that they have slightly different materials. If you do want to see more about the materials themselves and where they're all living, you can always drag your model down here and make a prefab out of it. Say, yes, I'm going to apply it to all of my children. And now that I have this made, I can open it up and see each and every material. If I scroll all the way down within this prefab, that's one way to look at materials. So now that I have that open, I could come down here to my standard material and just say select material and see that it's this one here. And then if I come to the rotor blade, I can do the same thing and see that it's this one over here. So they're actually different materials, and I'm going to want to override that so that I can control those two things together with the same material. So let's maybe get on, first of all, making these not static, making them merged so that they'll be merged together. And then we can figure out where we go from here. So first things first, I'm going to merge the nose, and I want to do all of this within my rule set so that I can apply it over and over again. So let me come into engine demo, and I'm going to create a new rule. Again, I'm going to reference the latest imported model. And then I want to filter on name because I know what the name is right here. And we're going to say contains, and we're going to type in NOS. So that is the nose that we're referring to. And then what I think I'd like to do is to set some metadata so that I can then search for anything with this metadata on it and apply a material to that. So here I can set a property name to something common, like a merge set with a value of whatever this thing is. So I'll just say it's an object. And then I also want to make sure that I turn off that this is static. And now we're basically going to rinse and repeat. So I'm going to come in here and do a new rule, get latest imported model. We're going to filter on name. And this time I'm going to search propeller. And then I want to set metadata. And I'm going to do the same thing. which I could copy and paste, but we're just gonna be daredevils and type it in ourselves. Then I want to set as static and turn that off. And now we're good to go. So we want to change this actually to nose, merge metadata, because that's where we're applying this. And we want to change this to prop, merge metadata, where we're applying it there. And I'm going to put these down just a little bit. Let's go ahead and just run it to see what we have. So now if I come over here, I see that I have propeller and I have metadata that has been applied called merge set with the value of object. Same goes for the nose. So that's great. That's exactly what I wanted to do there. So let me come back into my rule set. And now I'm just going to say get all game objects just to show that you don't have to use the same repeating get every single time. And so I'm going to say out of all the game objects, I want you to filter. And this time we're going to do on property. I'm going to leave off case sensitive. And we can type in what we have is our metadata here. So merge set and object. Then I want to go into the hierarchy and I want to merge all that have been selected. So this get is getting these two things. Now we're going to merge those two things. Then I want to set the name because otherwise it could be something that is not easy to understand. So I'll call this prop and nose. And then the last thing that I want to do is set a material. So we'll say set material, and now I can just drag in something. So here's one that I've made already called prop. If you don't have that, you'll just right click, create material, test. And then over here in the engine demo rule set, you could drag that in instead. There's no difference in these other than one I've turned to red so that I can see obviously when it changes. Just to showcase that this is happening all live, I will do this and I'll change it to blue. So now if we come back to this rule set, it should now have imported the model. It will now set the metadata for both of these. Then it will merge them. It will change their name and it will apply a new material. So let's hit run. This again is where the propeller and nose are over here. When we hit run, it should merge. And now we have prop and nose and we have a material assigned there, which is great. So now we've merged the prop and the nose and we've set the material. Now what I want to do is decimate something. And let's just assume that we want to decimate one part of this at a different level than everything else. And I feel like these hubs here are a little bit heavy. So let me maybe come up this way to this piece of the hub and its parent. And let's look at what this parent has that we want to emulate. So each of these look like they all have the same metadata. And I'm seeing this one here as maybe something that's obvious that I could set. So I'm going to search for these by their metadata and then apply a decimation to just those objects. So let's come back into the rule set. We're going to close this one down and we're going to create a new rule, get, and here we will do latest imported model again. Again, it's a bit of a either or there. Then I want to filter on property and I want to come over here and get this exact property. So I want the name to be here. Let me just make sure that I have this properly done. And then we want to come back out here and go to property and use this word here. So now it is searching for anything within the latest imported model that has this metadata on it. And then I want to do something like a mesh decimate. And instead of doing a quality, which has its own pieces in here, like surfacic tolerance, linaic tolerance, among other things, I'm instead going to do a target. And I'd rather not target a try count because I don't know what these are by default when they import. So I'm just going to do a ratio and say, hey, can you reduce these to 60% of their previous fidelity? I think that'll work well for me. So now I can run this. And before I do, I want to look back over here and see 2.1 mil. I'm going to hit run, and it will now decimate those pieces. You saw a little bit of a change, and now we have 1.8 mil. So clearly those are taking up a significant amount of the edge loops in the scene and the triangles that we have. I feel like that optimization did not hurt the fidelity of the model, so I'm going to leave that right where it's at. Okay, so there's our first decimation. Now let's say we just want to decimate everything to a quality setting. So I'm going to say decimate all. And here we can do a get latest imported model and do a mesh decimate. And this time I'll just set it all to poor so that it will decimate as much as possible. So here we're starting at 1.8 mil. I'm going to go ahead and run. And looking back over here, we're still at about 1.8. Nope, here we go, 1.6. It just computed. Now we're at 1.3, so it just finished the operation. 1.3 is not bad. So now we're down to 1.3, and let's say we want to then select anything that's a small object. Maybe it's under a certain size, and we can decimate those even further. So let's say get latest imported model, and then we'll add a filter on size. And let's say 0.1 is what we're going to search for. And then we can do a mesh decimate. And I'll make this a target with a, I guess we'll leave it as triangle count, and we'll just set it to maybe 1,000. I could likely do better than that, but let's just see what this gives us and if it improves our try count at all. So it's now running. It's now ran. It's brought us down another 0.1 million. So I'll leave that. I'm pretty good with that. Again, I don't see anything immediately noticeable in what has been decimated in a way that I'm worried about it. So I'll just leave this where it's at. If we were wanting to get closer to this model, I may be a little bit more protective over how much I'm tessellating or optimizing rather. But so far, so good. Okay. So I've done that, and maybe I want to even take, let's say, these bolts, and I want to take anything that is a bolt and compress it down further. So I can see there's a bunch of stuff in here that ends with or begins with DIN. So let me just shift select all that. And that looks to be pretty much all of my small bolts and pieces here. So again, we can use the naming convention just to make this very simple. I will name this decimate small. And then I will add a new rule. And in here we'll do get latest imported model. And then I will filter on name. So you can see how this gets a little rinse and repeat, but that's the idea, is that you're going to get, you're going to filter, and then you're going to apply something to the filter in general. So with this, without case sensitivity on, we'll just say DIN is what I'm looking for. And now I want to add in a mesh decimate. And we'll say that this is going to be a target ratio. And we'll put it at 50%. I don't believe we need to get into any of the advanced options. So let's just come over here, hit run, and watch the try count. And we're down another 0.1 mil. So that's pretty good to me. We'll call this one decimate bolts. And then let's do just a standard remove hidden. So I'm going to create a new rule, get imported models. So this time I'm just saying anything that's been imported. And I want to say mesh remove hidden. Within this, we can fine tune a lot of this. I'm just going to set it to high for now. And then come back over here and hit run. So now that has removed hidden components that we couldn't see from the exterior of the model. We're down to 1 mil even, which is pretty good. So we're we're slowly chipping away at this. Let's say then there's just a ton of batches in here. So we're at 2,343. So 2,343. And I want to bring that down. And right now, the fact that all of this is separate is kind of pointless. There's no reason to be doing this. So what I want to do is just merge by materials, because we saw that there were materials that came through and they appear to already be applied to what's relevant for these pieces. So inside of our rule engine, we can then just do after we name this remove hidden, we can then do a merge by material or something similar. And let's say latest imported, and do a hierarchy, merge, and then here we can say merge by materials. So now it will merge anything that has the same material. So this is where we've kind of planned for this by assigning the same material to the nose and the rotor, so that those will stay as one model instead of if they had kept their initial separate materials. At this phase, it would basically merge them independently and they would be separate objects. So I wanted to keep them together here. So that looks pretty good to me. We're looking over here and we see 2,343 as we mentioned. Let's go ahead and run it and see what we get after this merges based on materials. So it's now going to run this in the background. Just to make sure that I mention this, because I have rules in here that are taking a % ratio of decimation, every time that I've been running this, it's been further decimating pieces of this. The idea is that I want to run all of this once, so just to reiterate, typically I'll continue executing these and then I'll come back in and do a re-import of all of this at once. But you will see things start to degrade more than you are wanting them to. It's just through the nature of running percentages of decimation each time. There are a few ways to avoid this. One would be creating rule sets for specific parts of this and having all of the decimation in its own rule set. And then instead of running it all over and over again, I could come down here and in a new rule, just hit run rules and then drag in that rule set for decimation. And that way it wouldn't be running over and over again. But for now, I'm just doing it all inside of one rule set. So this most recent rule is to merge materials, which you can now see on the left. We have all of these different materials merged. You can see that all of the materials that came through in the default native file all have the name standard. So what we would likely do is come back in here and do something like we did earlier, where you can intelligently select a few pieces based on metadata or size, and then apply a new material, or you can use the switch material function inside of here if you wanted to get into that, which I believe is in modify switch materials. We won't go too deep into that today. For now, I want to get into one of the most fun parts of this, which is, let's say my boss comes by and says, hey, looks good, can you make that rotate? So I could just drop a standard C# script on top of this that gives me rotation controls, or I could add it into this rule engine at some point so that it automatically applies for anyone who's doing this in the future as well, so that they don't have to redo this rotation. The way that I would tend to do this, after I correct my spelling, so the way that I would tend to do this is by making a new rule, doing a get latest imported model, and then we're going to filter and filter on name. And because I want to apply this to my nose and prop, I'm just going to say prop down here, because at this point, we're now just calling this prop. And that is because it merged the material name. So this prop material is what merged in. The test material is usually what that would be called, but I was experimenting a bit with the names with the merging. So that's what we have. They all merged and are now named based on the material that they have. So let's jump back into how we would get this to rotate. So I'm going to search for prop, which is the name of this piece. And then let's say I want to add in a code that will rotate the parent of whatever the code is assigned to and allow me controls. So the way that I would do that in here is I would go into add and child. And then within this, I would create a new empty object called whatever I want. I think I'll call it rotation controls. And then I want to drag on a script that I wrote. And when I say I wrote, I mean Unity Muse wrote it for me. So just to illustrate what that looked like, I came into Muse and I said, write a C# script that will make the game object this is assigned to and its parent rotate on any of the 3 axes in a positive or negative direction. Let me choose which axis and which direction through selection boxes on the game object. So then I took this, I copied and pasted this into the script and then pasted the void update underneath here. And just to show what that looks like, it looked just like this. So all that I did was copy and paste this part here and then copied and pasted this in next and had the end brackets down here. That's all that it took. And I'm going to put that onto the rotation controls. And now I can see that I have a target, a rotation axis, rotation speed, and which direction. So because I wrote in the prompt to Muse, hey, I want you to control the parent of whatever I'm doing this to, I'm not going to target the prop object itself. I'm instead going to target this itself. However, I don't want this to have to exist within the hierarchy. I want it to pull in intelligently every time. So I'm going to make it a prefab called rotation control here. And then I can direct it at itself. And I can delete that out of the hierarchy here. And now when I run this, it will add this exact thing when I drag that in there. So let's see how this goes. I'm going to hit run. All right, so we have a rotating rotor blade that we have made with Unity Muse. We didn't have to write any C# code. And now anyone who's a designer or non-technical can get in here and change the rotation axis, the speed, and which direction it's spinning, just through a few clicks of public items, which is pretty damn cool. Last thing is I noticed that this model is flipped the other way. I could just move the camera, but in case somebody gets in here and has done something funky with the main camera, I'm just going to rotate my entire object 180 degrees because I noticed that at a parent level, it's already 180 off. So I'm just going to make a quick rule here. That is just going to be a get last imported model. And then we're going to, let's see where we're at. I believe it will be set transform. And we'll change this to -180. So that'll even it all back out. And now it's going to flip around, or should. So the last thing that I want to do is that now that we're in Unity, I can play around with making this look a bit better. So we have our main camera and a directional light. I would prefer to do some interesting things with like a global volume. So let's come down here, right click global volume, create a new profile, add an override for fog, do some volumetrics in here, which will be kind of cool. This is not a tutorial really on volumetrics or any of this stuff. So I'm just going to whiz through this very quickly. And then I want to create a spotlight. And I have a lot of stuff in here that's static, so I can set this to mixed. I can raise this up just a bit, increase the intensity a good amount, turn on my gizmos in the top right, and do something like that. Let's turn this up one more 0. That's pretty good. Turn it a little bit warm. And now we have something kind of moody that is neat from my perspective. As a more interesting way to light this, I'm also going to come into lighting and I'm going to bake it. But before I do that, I want to re-import this item one more time. because I want it to actually apply all of this. So let's use everything that we just did. We'll re-import the item. And in doing so, at the bottom here, we're going to be sure that we select engine demo as our rule set that we want to be applied after import. So I'm now going to hit import. All right, so this is now pulled in. If we hit play, it's facing in the right direction. We're down to just over 100 batches. We now have this rotor blade spinning. We can give these controls to anyone we need. Let's say they need it to be 1000. We also now have that global volume that we created, where I can now come in here and create something like a motion blur. So assuming that I didn't already do this in this tutorial, if I remove that, add override, type in motion, and you can see how this kind of layers on itself. There's a lot of goodness that you can create in this scene, even if it's like a templatized configurator that you can then just keep pulling assets into and reusing this lighting setup. I'm not saying this is a great lighting setup, but I think it's kind of fun. And there we go. So we're now down to, it's 122 batches. We're under 500K tries, among many other things. And the crazy thing is, from here, we can even go further, where I can grab this item. I can come into Pixyz, I can go to LOD, I can go to LOD Generation. And within this, it's going to now generate LODs for me. Let's say I want to add one more level and have this level actually be a billboard, so just an image more or less at the end. So 4 levels of LOD. I'm going to generate all. I'm going to let this take over for a minute, and it's going to theoretically turn off my main item, turn on a new item that has 4 levels of LOD within it, and I'll check with you as soon as that happens. And we're done. So that took not much time at all. Within here, I do have test. I want to make sure that this rotation is reapplied. So obviously this LOD part I'm doing manually, but just to show what we can do. If I hit play now, theoretically, that's still going to rotate properly. The neat thing is if I come up here, we now see that our LOD has been created. And looking at this, our LOD3 is quite literally 36,000 triangles. So if I turn this onto like a crossfading of my LODs, you really can't see it all when I'm moving between different levels of quality. So again, we're about here. I think when I go to LOD4, it's probably going to break a bit more. So I'm going to pull cold way down and pull LOD4 probably to 2% and cold to 1%, something like that. And now when I come back in here, I can see all the way out without the grid, without selecting the item, that we are all good. And way out here, you can still see the rotor blade spinning way off in the distance. We are sitting right at 36,000 triangles. So we did a massive undertaking and got this object, which I'll pull up in just a second and compare the numbers, down to 36K triangles at this distance and 100,000 triangles right here and 144 right here, which is pretty damn good. Hey y'all, so I'm over here editing right now and saw that the audio cut out in my outro, so just recording a new one. The key takeaways here are that I want y'all to understand that we went through the Pixyz plugin. We took, what was it, 2 million tries about to 100K tries or so. But the most important piece of that is that we're doing it in an automated way. So there's now the next person who comes after me, or me if I'm making my own job easier, will be able to pull in this asset no matter how many changes are made, as long as they maintain things like naming convention, hierarchy, metadata, then all of our queries and all of our searches and filters will still apply. And we can now ingest this thing, already have a spinning rotor blade on it, and it makes everything much more simple. Pull it into a templatized scene so that we don't have to relight a scene every time for design review, for marketing stills, whatever it might be that you're using Unity for. I hope that you all got something out of this. Please like, comment, and subscribe, and let me know if you have any questions. Have a great day. See ya.